Morning, everyone.
Yes.
Okay, thanks a lot. I would like to continue focusing on this question of how to make public transport more attractive and the role a digital vehicle or a digital train can play in that. Just a couple of words with regards to myself. My background is actually in physics and aerospace. I've been working in the airline industry for many, many years and only shifted over to rail and public transport about 5 years ago. So I have a little bit of background in two different transport worlds that at the end of the day are very similar with one respect, that in order to bring passengers on board of a plane, of a tram, of a bus, of a train, we need to be attractive, we need to have an attractive product, and certainly the passenger experience needs to be right so that the passenger is in the end, or our guest is in the end, happy with the product we are giving them. So, in fact, this is what I would like to talk about in a bit more detail. What exactly are those passenger expectations? In fact, there have been a number of opinion polls in the last months and the last year, especially in the context of Corona and how to bring traffic back and how to bring passengers back. And there's a very notable trend in all the opinion polls that have been made, that passengers have been saying, well, maybe I'll be traveling less in future, but it's more important for me to really make sure the travel works for me. And certainly I have certain expectations in terms of how the service level should be. So what does that mean? Let me give a couple of examples. The first one is about real-time information. Now you will say, real-time information we have today, so what's the problem? Of course, all my passenger information systems would usually be updated in real time. I have many vendors, probably everyone, who can send messages to a vehicle and messages back. But we need to take a step back at what is our passenger looking for, because they normally don't step on board of a vehicle, let's say on board of a tram, with a view of going from one stop to another, but usually they leverage on something that's very important in public transport, and that's the interconnectivity. So the strength in the efficiency of the public transport system lies in many ways of the interconnection stations, of going from one mode of transport to another one. And in fact, it's not unusual if I live, let's say, in a larger state and I want to go from a big city to a little bit outside, that I could have a journey of maybe 3 or 4 or 5 different hops where I go from one bus line to another or from one train to another or whatever. So what is important to the passenger at the end of the day is, how do I get from A to B, including all those intermediate stops, and not necessarily only, okay, I'm on board of the bus, so is the bus on time or is it delayed or whatsoever. Now, we have displays in most of the vehicles today. We have operations control centers that have an overview as a traffic operator with regards to the on-time performance of the traffic network I'm operating. But we also know that, in fact, we have what we call in Germany Verkehrsverbund. So the combination, the joint ticketing and the combination of different operators. And that is very important to also include in the information flow. So quite a number of operators have started to invest into additional information systems to help their operations control disseminate more meaningful information in case of disruptions, which is the way to go. But then, in fact, the big question is, how do I get that information to the passenger and display it and show it in such a timely manner that it makes sense? So this is one issue to look at, because we have different fleets, different vehicles, different ages. And of course, I can buy brilliant new trains and buses. I can buy super perfect new systems. But the question is, does it really make sense to rip out everything and replace? Well, of course not. So the question is, how can I actually leverage on what I have in the best way? So this is one aspect. The second aspect is good digital services in general. Of course, one aspect is the mobile phone and the app the passenger is using, which is a very important one. But sometimes we also have additional products we would like to advertise or show the status information to our passengers about. Let me give the example of the integration of rental bicycles, for example, where in principle, even though the passenger may not have made up their mind to actually use one, in case of disruption, it may be a good idea to change their plan. And if I would have the information 2 steps further on, there is so and so many bikes available, I would readily hop, but how do I get that information? And how can I actually integrate additional external digital services into my product and get them across to the passenger, not just in an app, but also in the context of the vehicle. This goes on and goes on. Of course, it relates to booking new activities, it relates to reliable connectivity. It also relates to relaxing a little bit during the travel. For example, using my smartphone. Now, many people will say immediately, okay, cool, then I'll buy a Wi-Fi and I buy the bandwidth for the passenger. There may be many good reasons why an operator doesn't do that, because in principle, everyone has a smartphone, they have a SIM card, so why should I buy the extra bandwidth and burden my budget? So does it now make sense to drop this altogether, or can I add additional levels of comfort to make, let's say, to supplement the use of passengers' own SIM cards and give them still a better passenger experience? I'll come back to that later. This is in the context of using, for example, streaming services where it might not work that well when I'm using my own SIM card and I'm going across rural areas or in certain environments. So are there ways of maybe offering a better experience without having to, in fact, replace the SIM card use and funnel that through a common Wi-Fi? And finally, the last point to look at is whatever new ideas I come up with. In fact, there is some operators who are saying, well, on longer routes where, let's say, the average dwell time of a passenger on my vehicle is maybe 20, 25 minutes, I would like to introduce new services and try them out. Let's say I'm operating a regional train and I would like to allow a vendor of my choice to come on board and sell fresh coffee. It's all a good idea, but how can I actually do that without, again, getting into costly projects, etc.? So I need flexibility, I need integratability. So, in fact, now I'm coming to the next point. The key challenge is that when I look at the systems installed in my vehicles, they're all designed like silos. Of course, we have very important initiatives like IT4PT that helps cutting part of the problem, but if we are looking at functionality, the systems are locked. Changes are costly, so if you have a fleet, let's say with passenger information displays from, let's say, 3 different vendors, to change the layout, introduce new updates, let's say, on every couple of days if you wanted to, is totally impossible. And in any case, it's going to be a very expensive undertaking. So the point I'm trying to make is that we have excellent systems in our vehicle, in principle, but they're all excellent on their own. And if I take a step back and say, I would like to see it from the point of view of a holistic fleet, or even from a point of view of combined operation of many operators in what we call a Verkehrsverbund, then we're starting to really reach the limits. So this is what we are addressing and what we are working on to change. We call this digital train. So in fact, our focus in terms of technology is to embed into a vehicle, first of all, what we call a cloud edge hosting platform. Now this diagram looks pretty complicated. Let me explain it a bit. So, of course, on your vehicle, you have all sorts of periphery. If you have a modern vehicle, it's connected by IT4PT. You may have proprietary interfaces, never mind, but you will have for your display some display controller. You may have access points. You will have a router. You have speakers with their own control system. You have cameras with a surveillance system and a recording system, probably in a separate box. You may have a passenger counting system with yet another box. And obviously, fleet by fleet, when you make those decisions, the number of architectures keeps growing. In principle, of course, all these peripherals could be connected to an Ethernet. So this is what we're looking at. We are, in fact, implementing projects where, first of all, what we're helping is to take legacy equipment and create interfaces that are IT capable for legacy equipment, number one. And number two, to have the Ethernet using as a transport network for all passenger-facing systems. So that in the end, the key component you actually need for your vehicle is a switch, a really good switch. Depending on the reliability and depending on the amount of functions, you may want redundancy, etc., but this is just a decision to be taken. You effectively need a hosting system, which is nothing more than a server. And if you in fact look at the technical architecture of the systems on your vehicles, you are using servers anyway, they're just locked away. But imagine you're using a server like you would be using Amazon Web Services or any cloud operator. And you use standardized container technology to invite the software vendor of your choice to host their application in your vehicle. So what we're doing is we're providing for the transport operators a cloud interface where you can, in fact, decide on your own software deployment. You can update every single subsystem in an open manner, so across vendors. You can decide on software updates, you can time it, you can assign it to different subfleets, you can have equipment or vehicles move from one operation to another, and you adapt your software accordingly, all under the control of the traffic operator. So how does this look like? This is just a reference example of one of the projects we've been doing. Don't look too much at the train. This is just an arbitrary train. It's not the real train we've been working on. So effectively, the way this looks like, at the end of the day, you have a switch, typically per vehicle, but there can be different architectures. You have a hosting computer somewhere. You have a clever antenna somewhere on board. There is very good antennas available where you can combine all connectivity, even the leverage on public radio like DAB+. So this is available as well. We can integrate that. So you can make all radio stations available to your riders on their Wi-Fi live without interruption. So all these things are sitting in the antenna. You connect it together. We help you to hook up your displays. As I said, either IP-capable displays, this is simple, or legacy, then we help you to adapt it, and your cameras or your audio system or whatever you have. So that's a typical architecture we are implementing. And of course, normally we don't have projects where operators come and say, can you please update everything? This is normally not the way to go. So usually there's a project that starts with, can you help us integrate the displays? We have a display fleet that doesn't really match the rest of our operations. And then you have an open system, and suddenly you can say, okay, cool, once I want to update my audio, can you please help me get the right components and update my audio system accordingly? So typically, of course, one company cannot do it all. I mean, first of all, I've said that what is important to note, the software is open, so the applications are actually normally coming from partners. We are providing the hosting, we're helping you to integrate, but we don't write all those applications. We're working with partners. And of course, we're using standard components from established vendors in the markets. So typically our partners are listed here, but depending on the case and depending on the vehicle, obviously we are open in terms of integrating and working with partners. It could be a different combination of equipment. So this brings me to an end. I have another slide that shows the key advantages, but I think I've already explained that during my presentation anyway. So if there are any questions, please go ahead and